Hello and welcome to Learn Synthesis with Pure Data, Season 1, Episode 7. In this episode, we're going to see how MIDI Pitchbend can be used to control the pitch of a synthesized audio signal, and we'll be adding that function to our synthesizer. Okay, so first of all, MIDI Pitchbend is part of the MIDI protocol, and it is kind of like a controller, but it's not officially the regular continuous controllers that MIDI has, like the modulation wheel and all the expression and volume pan and all the other continuous controller messages that are a range of 0 to 127. MIDI Pitchbend actually has a range of 16,384 different values. This means that it has a much higher resolution than the other controllers, and that's needed so that when you bend pitch, you get a smooth, continuous bend across the frequency spectrum that you're bending, and you need that resolution, otherwise you would hear it kind of like skipping through different pitches rather than actually bending it smoothly. It's a 14-bit controller, and 14 bits of information basically give you 16,384 different values. So with that in mind, we'll see how we can apply that to our synthesizer. Before I begin doing this week's addition to our synthesizer, I want to point out something I did with the amplitude envelope module, the ADSR module that we made last time. This is something I forgot to actually implement in that video. I'm going to right click and open it. Basically, you'll see this is a patch. This patch I just opened and haven't done anything with. And you see the ADSR sliders actually have values right now. The way we left it off last time, everything was zeroed out, or basically at the bottom of the slider. Now the sliders, I didn't make their bottom part of the range absolute 0, but basically, especially with the sustain all the way down, you didn't get any sustain. By default, you would actually have to move these sliders to get and create an envelope. But what I did is I basically put in default values, and I'll show you how. Anyone following along should add this, or you can use your own values for the default. I just selected some that allowed me to actually have a reasonable envelope by default, so that when the patch opens, it actually plays with the envelope. So what I did is I made a load bang and message box. This message box sends the value 1500 to our door slider. Remember, this ranges from 1000 to 5000, and it's basically the amount of milliseconds that any of these sliders gets multiplied by, at least attack, decay, and release, not sustain. But attack, decay, and release gets multiplied by that to select how many milliseconds each of those segments of the envelope would be. You could actually have it just start at 1000, and that would be fine. I put it at 1500 just because a little bit longer for these events, for these sections of the envelope, sounded good to me. That's all. And then I have a message box here that's hooked up to the load bang. For 0.75, that is hooked up to sustain. So that way, right now, by default, when the patch opens, your sustain level of amplitude is 75% that of whatever the peak level of amplitude is coming in based on the velocity at which you hit the key. So this allows for a pronounced attack to the note being played, and it lowers it down to 75% of what it was for the sustain level. And I just found that to be a rather pleasing default sound to have to start. And then here I have 0.1 of a message hooked up to the load bang that starts off our attack value at 0.1. It's a quick attack, you know, without being too super quick. I don't know. I mean, like I said, you can experiment with what values you'd like your envelope to start with. And then the low bang also hits this. This is 0.25, which are the starting settings for decay and release. It just seemed to be a good amount of decay and release time for a starting sound. So I'm going to play my MIDI controller here. So that's basically starting off with a good amplitude. Now, I do hear little instances of artifacts in the sound yet, but they're not due to the ADSR. This is something that will be resolved. In fact, in what we do today, it basically has to do with frequency. As frequencies change, you can also get artifacts if there's a jump from one frequency to another without a little bit of smoothing like we've been applying with the line object. And we'll be adding that as part of what we're adding today. So let's get on to today's mission, which is to add Pitchbend to this. First thing I'm going to do is open up the MIDI input here. Now what we want to do is add a visual display slider that will also be able to be used in case you don't have a MIDI Pitchbend, or if you're testing out the synthesizer without the without an external MIDI controller. Sorry, I needed to pause to cough there. So the slider will be made just like these. Like right now, you could literally type in like a MIDI note value like 69 for A440. Type in 100 here. Then type in 0 to turn off the note. So that's a way to test this if you don't have a MIDI controller right now. And I'm going to put in a slider for our pitch bend. But I will do that as we construct this. So we have note in for note and velocity values coming in. The object to receive MIDI pitch bend data is simply bend in. Now once again, we want this only to be received when it's on the selected MIDI channel. So I'm going to copy this thing here, the select, the one message, and the trigger bang to bang the 0 message that basically turns on and off the spigots. Hitting Control D, that would be Command D in Mac, and I'm going to just grab this one, bottom of the blue highlighted stuff, which is our duplicate. And we'll line it up right here with its right outlet, which sends out the MIDI channel number that this pitch bend data was received on. And so we're going to add our ability to open and close spigots to receive what's coming out of the left inlet or not? Meaning, do we want to actually receive this MIDI Pitchbend data? Is it for this synthesizer on this MIDI channel? So we do want to hook up the channel box here. Come on, stay a circle. There we go. To the right inlet of the select here. So that way the channel gets sent in, so select knows what channel to look for. And then we're going to need a spigot. Control whether or not this MIDI Pitchbend data is allowed in. So I'm going to hook this left outlet of bend in. Now this is actually the MIDI Pitchbend value that comes in. And we'll hook up the 0 and the 1 to control that. Okay. Now, we don't need any extra patching like we have here for notes and velocity. We want basically this data to come through. But we're going to send it up here first, so it'll be on our display slider, which will basically display what the MIDI Pitchbend values look like right now, or basically where, if you had a MIDI Pitchbend wheel, where it's at, or where you are on a touch strip, if you have a touch strip Pitchbend controller. So we're simply going to send what comes in here by using a send, S space, we'll say MIDI underscore bend, and we're going to say RECV, receive, because this will go to the receive of the slider that we're putting up here. Now I'm going to use the shortcut Control-Shift-H. Oh, wait a second. Let me check the put menu. Horizontal slider is actually Control-Shift-J. I'll just click it here since I'm already here. Yeah, it used to be H, but it was changed to J a few versions back. Now this slider is going to display whether pitch is being bending or not, but we got to change its properties. It starts off with the default range of 0 to 127. We don't want that because that's not Pitchbend value range. Now, I said before that Pitchbend has a range of 16,384 different values. The actual values are a range of 0 to 16,383, which, counting the value 0, means 16,384 different values. So that's the minimum and the maximum of this slider. Here, our receive symbol shall be put in. We already made that. Oh, my send didn't take effect. But what I wanted to type was send and have it be, oh, I think when I typed Control-H, it erased it. All right, so anyway, I'll put that back in. MIDI underscore send underscore receive. And we want this also to then send it back out again. MIDI underscore bend underscore send. So that way the value gets sent right back out again. We'll give this a label of Pitchbend, using the full text there because it will fit right above this thing and not get in the way of the rest of the display here. Now, as I'm seeing here, we do have a little extra space to make this wider. Now, we can't make it 16,384 pixels wide. That'd be too wide for our area and for the screen. So we're just going to make it a little bit wider so it can take up a little extra space. The wider, the more resolution you have when clicking the pitch bend graphic here to actually bend pitch. Let me see here. Looks like, but right now I'm just doing this for visual nicety. So I am going to, let's see, how about 140? Hit apply and see how wide that is. Like I can make it a little wider. How about 150? Yep, leaves a little margin at the edge, which is good. Okay. There we go. Now I do need to put this back in. Send S space MIDI underscore bend underscore RECV. So right now I'm using the keyboard controller that I have. I'm not seeing Pitchbend data actually come in. Oh, and I know why. The spigot is closed because this channel message never got sent. It's all hooked up, but it never was sent. When the patch opens in the future, the load bang will make sure it's sent, and whenever someone changes it off of its default of 1, that will be sent to. So there we go. I just typed 1 again. That told select what to look for. And so that way any MIDI pitch bend coming in on channel 1 now should come through an open spigot. There we go. As you see, the slider's moving. And my touch strip does have a center like ridge on it so that I can find where the center is. And it allows me to have that there. Now that being said, it's always good to have a way to make sure your pitch bend is centered out, because this is going to be set up so that we can bend pitch down and bend pitch up. But when you want to be on the actual original pitch unbent, you do want it to be able to go back to here. Now, if you have a MIDI pitch bend wheel on your controller, it's usually spring loaded to go back to the center when you let it go. When you have a touchpad like I do on this mini controller, smaller controller, more common to have touchpads now, it does have a ridge to get back to the center. Although I'd like to see here, just for the hell of it, let me make a MIDI, just a number box just to see. I'm going to be getting rid of this, but just for my own curiosity, I want to see the values. Bend all the way down, we're at 0. Then I go all the way up, 16,383. Then I go to the ridge in the middle, 8,192. That is accurate. That's what it's supposed to be. I was just making sure that when I touch that ridge in the middle, it does zero out. But it's good to have a failsafe here to make sure you can zero this out if you need to. We can do that by making Control-Shift-B for a bang. I'm going to locate it right in here, so it's obvious that that is to center out your pitch bend. Now what we're going to do is actually make a message 8192. Take the outlet of this bang, hook it up here to 8192. And then the outlet of 8192 is going to go to inlet of the slider, which is its upper left corner. You don't quite see the inlet right now, but there. And then I'm going to have the load bang also hit this 8192 so it goes through. The reason why it's a little twisty here is this, well, actually, let's have it go through the bang, is so that you don't see the 8192 message coming through on the display. You just see the centering bang, but the bang has to hit the message and the message needs to go to the slider. And then the load bang hits the bang, so that way when this opens, your default going to be on a centered pitch. So let's close it right now and look at this. I'm going to bend this down, then hit the centering thing. Good. There you go. That way when the patch opens, you're not default in some bent pitch, because the slider will by its nature start at its minimum value, which is 0, whenever the patch is loaded. Because when you close a patch, it doesn't save the value of where the sliders are at or where the number boxes are at. So it's good to have defaults in, just like the ones I put in earlier for the ADSR. Okay, so now we have all the mechanism we need to kind of get this MIDI pitch bend stuff in correctly. Now we're going to open up our oscillator and add this. Incidentally, I want to just say at this point that we are going to have a second oscillator, but we need to finish up this one, have all the features in it, so that when we duplicate it, our second oscillator will have all those features. But we'll have to duplicate it and kind of change its symbols on the inside so that it's an oscillator too, and the sends and receives don't get confused between this and the new oscillator we'll make down here. Let me right click on this and go open. Now that's in another video. That'll be in the future. We'll add that. Okay, so here we have our note data coming in, getting converted to frequency values, and going to these actual cable oscillators here. I'm going to disconnect all these cables because we're going to replace this M2F with something else. We're going to make a subpatch for MIDI pitch bending. Let me zoom out so you can see this appear. Just like whenever we make a subpatch, make an object, type PD. I'm going to name it OSC_1_bend. That's just a name. Just want to keep it consistent since it's the pitch bend for oscillator 1. You see this window came up. That means this is the subpatch window for this subpatch. Now watch this. We're actually going to make an inlet on it to take the data in. Control 1 to make an object and type the word inlet. Now we'll open up this window again, but I just want to, well, actually I don't need to close it to show you. See, after I made an inlet on it, you see there's an inlet that appeared here. When you make inlet objects, it basically puts an inlet on the subpatch. That way we can hook up our note values coming in, go to this subpatch. And then, just so you know, if this is the only inlet we'll need, but if you, as you add more inlets, they will appear here in order left to right. So in the order that you put them in here, going left to right, they will appear on the outside in that order, left to right. Now, when you add the next one, like the second one, it'll immediately go to the right corner because it spaces things apart that way. If there's only 2 inlets, they're on the left and right corner. When you add a third, it'll be left, middle, and right corner. So the way it's spread out is automatic and controlled by PD, but they are going to be correspond to the inlets on the inside according to their order left to right. But we only need one for this one, so that's it. Now I'm making this window big because there's a number of patching here. I mean, a number of patching things we need to do. This is going to be fairly heavy math coming in. Well, not heavy math, not for mathematicians, but compared to what we've done so far. I'm moving this inlet here a little bit so that what I put down below visually will make a little more sense. First thing coming in. This is now coming in as MIDI note numbers. We got rid of the M to F, so MIDI note numbers are coming in from the MIDI input submodule. So those note numbers are coming in. Now what we want to do is not convert it to frequency just yet. There's a useful thing we can do before that happens. We're going to take an object here that's a multiplier, star base 12, or not star, excuse me, plus base 12. Now what this is the MIDI note numbers coming in. Let's just say, for the heck of it, it's good old 440, which is MIDI note number 69. Well, this is going to add 12 to it and give us the result here. And just so we can see this happen, we'll put a number box there so we can see. And actually, just so I can do this internally, so you can visualize what's happening, I'll put a number box there. Now over here, I'm going to make an object that's a minus 12. And I'm hooking this up to the left inlet. Whatever MIDI note number comes in, over here, we're going to add 12 to it. Over here, we're going to subtract 12 from it. Put the number box there so we can see the results. So let me just do that. Let me type 69. Add 12 to it. It is 81. Subtract 12 from it, 57. Now what this means in MIDI notes, 12 is semitones, because each MIDI increment between 0 to 127 is a semitone, lining up to all these notes. Middle C is 60, A440 is 69. So if you want the octave above and below, you have to plus 12 or minus 12, because the 12 is an octave in MIDI as well as in semitones in music. An octave is 12 semitones, meaning 12 actual note values or note designations in our equal tempered Western civilization notation system. So it all kind of works together. What I'm doing here is I'm going to be finding out, MIDI is determining for me whatever note's being played. This is what the octave above it is. This is what the octave below it is going to be. And I'm going to be basically setting up this pitch bend to bend up and down octaves. And of course you can leave it somewhere in between, but when you turn it all the way up, it should go up an octave. When you turn it all the way down, it should go down an octave. And when it's centered in the middle, it should be whatever the original value is. Okay, now we're going to convert to frequency. Now you could set up a mechanism that would change this, like you could even put a number box in the MIDI input section and have it change in semitones according to what the user selects, how much it'll bend up or down. I'm not adding that right now. You can see how this works, so if you want to add something like that, you can. But that basically, you know, usually bending up and down an octave is typically what people use when using pitch bend. Sorry about that. I had to cough again. So anyway, we want to be able to convert, or to actually convert, what the center pitch is. And then we need to know in frequency values also what an octave above it is. And then we need to know what an octave below it is. Okay, so this stuff gets calculated. And basically I can add number boxes below these. These number boxes are unnecessary, and eventually, you know, what I do when I'm building things is eventually, after things are tested and working fine, I'll take the number boxes out, because it's just an extra thing that being done, displaying a number, that's not really necessary. But I'm putting them in here so you can see what we're actually doing. And I'll put a number box. Well, whatever number it is will be the same as what's coming in here. So actually, here's what I'm going to do. Let's just have this inlet hook up to these. Directly. And then whatever the actual pitch is, like the note being played without the pitch bend, will display here and go down here, where I don't need to put a number box below it again to display what it is. Although maybe it's good to put a number box below this so we can see what the frequency value is, because that's what this is doing, converting MIDI note numbers to frequency. There we go. All right, so now we're going to take over here our bend value. So we can make a receive, R space. And what are we going to receive? We're going to receive MIDI bend send with underscores in between those words. We see MIDI underscore bend underscore send. That is the send symbol from the pitch bend display. That slider display right there. Or what am I doing? Oh, that's right. It's even further. This is a subpatch within a subpatch. But you saw me make it earlier. I don't need to show it. But basically that slider we have made before. That's its outputs coming in here. And now, what we want to be able to do is have it calculate numbers of how far it gets down to this and how far it gets up to this when those different bendings happen. So what we're going to do is make this easier on us. We're going to take whatever bend values coming in, and actually, just to visually make this lesson better, I'm going to have it display it there. I just saw that this. Okay, there we go. So we'll see what the MIDI bend value is coming in. And then what we're going to do is set up something here. First we're going to use a select. Well, actually, we're going to make another object first. And this is one I don't think we've used yet, called Moses, M-O-S-E-S. And then I'm going to put a space, and I'm going to put the number 8192. Now, what Moses does is whatever values are coming in to its left inlet, it's going to send out anything that's below that value to the left outlet, and anything that is that value or above to the right outlet. So remember, before we saw that 8192 is the center point of the MIDI pitchbend range. It means pitch is not being bent. So the note value should come through as it is, or the frequency of the note value should remain that frequency and not be bent up or down. So we're going to set up something here to find out if that's the case. I'm going to take a select object, SEL8192, because this outlet sends out if things are this value here that we set up as a creation argument or above. So if it is that value, a bang will come out of this select object here, and we'll have that do something in a bit. If it's not this value, if it's not 8192, that means it's something above it, and it'll come out here. Now, if it's below it, it comes out here. So we'll set up another number box. Remember, these number boxes I'm just putting in just so I can display the data coming in, so it makes more sense to you what's actually happening. Now, what I need to do, let's start with one aspect of this whole situation. What happens if it's below 8192? Then we want it to control how further below the actual frequency of the note value we want to bend it. And what we can do in order to do that is basically convert this by dividing it by 8, because the values that will be coming through here will be the number 0 up to 8191. So let's divide it by 8191. And what that gives us as a result is a percentage. 8191 divided by 8191 will equal 1. 0 divided by 8191 will equal 0. And you'll get all the things in between as percentage values. It's basically a range of 0 to 1. So we've converted the pitch bend numbers coming in that are below the center frequency to a percentage, which we can then multiply by frequency values over here to basically control to what degree it's bending down. Now, the thing is, to make this work better, or to make more sense, if the pitch bend wheel is bent all the way down, it's going to result as a 0. If the pitch bend wheel is bent only slightly down, so much so that it's at 8191 instead of the center position of 8192, it gives us a result of 1. I'd like to invert that so that we get a range of 0 to 1, but 0 meaning closer to the center, and 1 meaning bent all the way down. But actually, I'm going to change this now. I'm going to make this 8192. Because believe it or not, if it's 8191, instead of being a 0, it should be slightly bent. So this result here, dividing it by 8192, will not give us a 1. It'll give us close to a 1, If it's bending down just slightly, it could be 8,191. It'll give us something that's like 0.99 whatever, something like that. Okay. Well, let's just see that first of all. Let me just type in 8191 here. We get a result of 0.999. Okay, that's good. And if the pitch bend wheel's bent all the way down at a 0, we get 0. Now I'm going to invert that. I'd like our percentage range to be basically going from a low number like 0.001 to a high number, well, the higher end of the range, 1, as it bends down. So that means we need to invert this, or basically make it the opposite of what it was. And we can do that with this by making a swap 1 object. Oh, I just hit Control 1 and it didn't make an object. Oh, it made it over here. Okay. Swap 1. In ranges of 0 to 1, you can use this technique to invert things. What swap means is anything that's coming through the left inlet is going to go out the right outlet. Anything coming through the right inlet or is a creation argument will go out the left outlet. So when our range comes in here, that number is going to come out here. And this number, since we have a creation argument, instead of receiving something through the right inlet, will always be 1. We're going to get a 1 out here and then the other number here. And if we put a divider below this, what we get as, and then hook this to the right inlet of the divider, what we're going to get is 1 divided by this number coming in, which will give us the inverse. And we'll display that in the number box here so you can see that this is happening. Remember before, a 0 coming through before was giving us a 0. Now if I type 0 up here, sends it through. Hold on here. 0, enter. Okay, the 0 comes in here. Its result is 0. One divided by 0. Oh, okay. Hold on. I'm sorry. This is supposed to be a minus sign instead of a divider. Put a 1 in up here. Well, actually, let's put a 0 in up here. That means we got our pitch bend bent all the way down, and now it results as a 1. And we're going to use that 1 to signify all the way down. Now let's find what 8191 does. 0.000. There should be a 1 or something after that. I think it's just not wide enough to display it. Or maybe typically a plus sign gets displayed if it's not wide enough. Let me just do this as a, just for the heck of it. Let's make its width 12. Aha, so then it does display the number 00012207. So it's a really low number. Now let's put something in the middle of that range between 0. Let's just say 4,000. It should be close to 0.5. And it is at 0.517. Okay, so yeah, we're correctly getting percentages here of basically to what degree are we bending the pitch down. 1 meaning all the way down, 0 meaning hardly, well, you're not being bent, but something that's close to 0 would be like hardly being bent. Something that's close to 0.5 means you're about halfway. and basically everything in between. So we're getting a range of basically close to 0 to 1 to see how much we're bending down. So now what we need to do is when we get a MIDI note number in and it converts it to frequency, what we need to do is take that note number frequency value and then find out what the octave below is, meaning the farthest down the note can be bent. And we need to subtract this from this. So that way, for example, let's put 69 in as MIDI note 69, which is A440. I'm not seeing frequency come out here. There should be a number here. We're correctly getting MIDI note number 57. This is weird. 7. There, it did it. How come it didn't pass through before? Oh. That's because yeah, I should have left things the way they were. We're going to get the MIDI note number out of here because when I typed it in here, it was only going to the center. It wasn't going to the side. The number 57 was just in there from before when I had done it before I changed the patching here. So 69. There we go. We're getting our frequency value 220, which makes sense because octaves in frequency values, the octave below is half the frequency of the octave above. And this 880 is twice the frequency because this is an octave higher. Octaves are doubling in frequency values as you go up, and halvings as you go down. So there we go. Now, what we need to do to calculate the distance between the center value in frequencies in hertz, what is the distance or the differential between frequency value and the frequency value of the octave below? Because that will give us the following. Minus. We need to take this and subtract this. But now remember, math values don't calculate until something's coming through the right inlet. Like the left inlet here will not calculate unless something comes through the left inlet or this is banged. So we have to set up that thing that we've set up before, a trigger bang float. So let's say you're holding a note and then bend the pitch. Well, the bent value will come in through here. And so if this value is received after this, it won't go through unless it's banged. And I hooked this up wrong, sorry. Oh, did the wrong cable. 440 goes to the left inlet of the subtractor. The float, meaning the number here, which is right now 220, when that comes through, that goes into the math object there to be subtracted from 440. Or whatever values of the notes and frequencies coming in are. And then the bang of the trigger hooks up here. Make sure it calculates. So let's put a number box below. I'm going to type 69 again. And 440 minus 220 equals 220. Now that's not going to be exactly that for every value. Let's go up an octave and type in 81, another A. There, 880, subtracting 440. Oh, yeah, that does equal 440. It's not always going to be the same number here. It just happens to be that case from the numbers we're using. Or let me see here. 75. We get a value of 622.2. That's that. Oh, it looks like it will always be this value. Well, that's true because since you're subtracting the octave below, which is half of this, since you're subtracting half of the frequency from itself, you'll always have a remainder or a result of half the frequency. But that's if you're using octaves. I like to set this up so that maybe in the future I will have the actual range changeable, where it won't always be an octave or 12 here, where you can have it bend up and down different semitones. So I'm going to continue to set this up the way I am, because in the future, if we want to be able to adjust how many semitones it bends, we can easily do that by just having new numbers come in here. So I'm going to continue the way I'm going and not just say, okay, whatever this number is going to be the result. Because if it's not an octave, we won't be getting the same thing where the difference between the center frequency and an octave below is always the same as the octave below's frequency. Okay, maybe I gave you too much information here. Let's just go on and keep doing what we're doing. Now, the thing is, what if we're not bending all the way down? Well, this number needs to be multiplied by how much we're bending down. Sorry there. And we're going to be doing this calculation with the other side too, as to how much we're bending up. So what I'm going to do, make a trigger, bang, bang, float, float. Because this is going to be going into the left inlet here. And it's going to bang the right inlet here. That way, whenever a value comes through here, like you move the pitch bend wheel, this value changes. So whenever that changes, we need to make sure it does the calculation even though nothing new is coming through the left inlet, like the note is being held at where it's at. And here, whenever you move that wheel, we want it to recalculate. So what we're going to get here as a result is basically to what degree is it bending down. Okay. Now, what needs to happen next is we need to provide a frequency value of where it's at. Like basically, this is calculating how much below the center frequency it is being bent. Now what we need to do is give that frequency, which really means this number is going to be added to this. So I'm going to make a plus here. Or no, minus is going to be subtracted from it. So we're going to hook this up to here. No, we're going to hook this up to the left inlet, because this is how much frequency is, and this is how far below that frequency it's being bent, so we need to subtract it from this. But once again, since we want it to calculate, we need to make the trigger bang float, so that way the number that's coming out here, which is the float coming into the right inlet, will also be banged so that it calculates. And then let's put a number box there to get the result. So let's put in some values to see what this whole means. I'm going to put this at 8192, meaning no bending. And the MIDI note is going to be 69, 440. So 440, it's finding out, yep, the bottommost value that it can be bent to frequency-wise is 220. Now, how close to 220 is it? Well, since there's no bending happening, because I put it at 8192, which is the center point, there's no bending happening. So what we get is a 0 here. And that 0 gets subtracted from the frequency value. So we get 440. So that way, since we're not bending, 440 is going to come through. Now let's change this, and let's say we want to bend it all the way down, which would be 0. Well, that means we're now bending it down to 220, which is correct because we're bending it all the way down the octave to 220. Now let's get something halfway in between, somewhere around 4,000, 4,050, something like that. Now we're bending it about halfway down. A440, it would be like about halfway to 220. And that would be 328. In that ballpark. Halfway, let's just say in round numbers, 110. 440 minus 110 is 330. You know, yeah. Because we're not bending exactly halfway. So this is close to it, so it's working. We're getting our frequency values of how far we're bending down. Now we need to do the same thing over here for how far we're bending up. So let's just start off here with a TBF, because we need to first calculate how far we can bend up. And so what we need to do is subtract this from this. So this will be 880 minus 440, or whatever numbers come through. Since this is actually going into the left inlet then in a subtraction, we need to put the trigger bang float there actually. Sorry about that. So this goes into the left inlet in that the upper octave, or the highest point of our bend range, is then the number that we're going to subtract the center frequency from. So what we need to do is make a trigger bang float here. Now this is already going out to some other things. So I'm going to disconnect these, but remember what they're connected to. The left inlets of these. Okay. trigger, bang, float. Now the float is this number. It will go here to this left inlet. And then we need to have the bang, the left inlet here, go to the left inlet here to actually calculate. Now this float also needs to go where it was going before, which was the left inlet here and the left inlet here. So for the lower frequencies, whatever your center frequency is going to be the frequency value that you're subtracting from. For the upper frequencies, it's going to be what gets subtracted from that upper range. So here is where we would get the result. Type in 69 again, so it goes through and calculates. Yeah, 880 is 440 hertz above 440. Alrighty. So then we need to find out here a multiplication by this percentage over here of how much is actually being bent based on the wheel's value, for the pitch bend's value. We need to multiply over here. Take U and multiply U by that percentage. Here's the actual percentage that goes to the right inlet. And then we need the bang so that as the wheel moves, it does get calculated. And then we'll put a number box below to get the result. And then just like on the other side, we need to do trigger, bang, float, where now what we're going to do is calculate how far up in it's being bent is being calculated here. We need to add that to the center frequency. So we need a plus here. Take this from the float output there. Hook these up as we do. And then we'll get our result down. Okay, so let's test this out. Let's put 0 in again. So we're not bending. MIDI note is in, and this does all its calculations. So I put in 0 here to not bend. Oh, that's the, I'm just not thinking. Not bending is 8192 in pitch bend values. So for not bending, 8192's come through. That's a 0. That should be zeroing out these. Well, actually, no, it isn't. And I see why. First of all, I never completed the upward bend section of this, nor what's supposed to happen if it's 8192. This actually comes in last, but this is what we're going to do here. If it's 8192, this is still at 0. Things didn't change here because nothing came out of the left inlet of Moses. Alrighty. Now, so this is still as if it was bending all the way down. The 8192 came out here. We need this to basically okay, let's do this first, the calculations of it bending up. Now this is going to be, we want to make this a range of, I'm going to do this, subtract it from 8192, because if it's bending up, its range is from 8192 up to 16383. So if we subtract 8192 from that, we'll get the result here. And then what we need to do, put in this case, the divider, 819. For here I had a divider 8192. Over here, I think it should actually be 8191, although I'm going to test it. See what our result is. So let's say we bend all the way up, which would be 16383. That means we get a full 1, which is what we want. That means it's being bent all the way up. Put you down here, just like the one over here. And we're going to extend you out all the way by making your width 12. So we can see those numbers with lots of things behind them. Now, let's do this. I'm thinking maybe I don't need the select here. This select. Let's see. I'm going to take it out, because this should still deal with all contingency. Let's say it's at 8192, which means no bending. We get a result of 0 here. Good, which means no bending. Now what I'm thinking, I just realized this. I have this trigger bang bang float float. Changing both these sides. It shouldn't be like that. It should just be a trigger bang float for this side. Because if you're bending down, it should only really have to calculate over there. This calculation on this side would really not be necessary. So let me take this out, sorry. Trigger, bang, float. Left inlet of the multiplier, and this is the right inlet. Now, we'll just need one of these over here too. And this will go to this side. Okay, so that will give us a result there. Let's say MIDI note 69 is played. And we're not bending pitch. This side becomes 440, which means no bend. This side's still at 220, but this only gets calculated if things are below 8192. So only if you're bending down does this side become relevant. Now let's say we're bending up all the way, 16,384, or 383, sorry. Yep, we're bending up to 880. Now let's just do halfway, like something like 12,300, something like that. Close to halfway. Yep. We get 66.6. Because it's not exactly halfway, but it's close. And so there we go. We actually are getting the right values for being able to control how much we're bending down, how much we're bending up, or not bending at all. Now, I have a feeling that there is going to be more patching necessary, because every time I've done this before, there was another step I needed to do. But let's go for it anyway. Make an outlet here. Hook both of these up. Now, whatever the current value is, that's what gets sent out. Because basically when new values are coming through here, they get sent out. So if it's not bending down, this doesn't get sent. But on this side, when you are bending down, then these will come out. In the past, I put spigots in here to control whether these are coming out or not. So we got to check and see if we get a smooth bend or not. I'm not putting in spigots yet. Let's see if we need them. Okay, we're just going to test this with the one side. And this is how we're going to test it. We're going to close this. And we're going to go here. MIDI note 69. We need to hear sound, so let's put a velocity of, let's say, 63, halfway up. Yeah, the center's really here. Okay, let me test it with my controller. Yeah, the resolution on that Pitchbend touch strip isn't great because I could actually hear increments here. But here's something we also need to do. Things are working, but remember about smoothing things out before? Eliminating those artifacts? We're going to do some of that here. We're going to put our good old friends Pack F50 and line tilde right here. Oh, we need to make this an outlet tilde for it to connect. Because remember, the output of line tilde is at the audio rate. So that way, as frequency changes, whether it's by notes being played or by pitch bend, there's going to be smoothing here to smooth it out. Okay, so we can close this now. And fortunately, our tab oscillators do receive frequency values at the audio rate. So nice thick audio cable will connect. And I'm going to connect it to all of them. If you don't mind. There we go. Now, let's just play the keyboard. Now hold a note. There we go. That can also be tested, as I showed you before, if you don't have a MIDI controller right now. Type in a note number like 69. Turn on your velocity, halfway up 63. Then move this. There we go. Then zero out your velocity to turn off the note. So there we have it. But now I'm just going to show you one more thing. We are going to add the ability to change how much being bent. It's not going to take long at all because of the way I set this up. I have a number box here. This is the number 2 box. In other words, the ones that can be actually, let me just, since these are already sized well, let me just take one of these like channels, for duplicate it, bring it over here, and I'm going to go to its properties and change its label to amount. Now its range, this is basically how many semitones do you want to be able to bend up and down. Let's set 1 as the minimum. I mean, you want to, there's no point in having your pitch bend sent to not bend at all. I mean, just don't bend it if you don't want to bend it at all. And then how many octaves do we want to be able to bend up and down? How about 2? So 0 to 24. Let's change its send and receive symbols. MIDI, amount, send. MIDI, amount, receive. Anything else that I want to change about this? Nope, there's nothing else that needs to be. Let's see if it fits graphically though. Put it right here. People know it has to do with the amount of pitch bend. There we go. Save, close that window. Now we're going to go back into our oscillator and into our pitch bend area. And what we need to do is just set up a receive here. Receive MIDI amount underscore send. And then this goes into the right inlets of these. Now the thing is, I have the creation argument of 12 there. And in fact, 12 might be a good default amount for the bend amount. But it would make sense for that to be displayed. As it stands now, this should work. But let me do this, just so I don't forget. We have a load bang here, load banging in default values. Let's use it to also bang in 12 here, so that from the start, by default, your pitch bend will bend 12 semitones or an octave. Okay, now let me play with my controller. Alrighty, now let's have our bending extreme just set to, how about 1, which is 1 semitone, so it should only bend up half step. Now, if you want to be able to bend it a perfect fifth, that would be 7 semitones. Retype in there. There we go. Let me look in here. I want to check here our values. We're going to go into the subpatch for the bending. Our amount is already set to is bending down. For some reason, to me, that didn't sound quite right. Let's give ourselves 69. Yeah, that's fine. Yeah. Yep, that's fine. So there we go. We do now have pitch bend on our synthesizer. And things are all smoothed out, sounding good. We are going to continue building this thing, but now you see how pitch bend can be implemented into audio. It sounds nice and smooth. Let me move this over. I'm going to do a screenshot. Bentley. you found this useful, please do hit the like button. Helps me out a lot. And subscribe if you want to. If you're at this part in the series, haven't subscribed yet, please do. Because it helps my channel in getting these videos out there. Alrighty, well, that looks like it for this week, or for this episode of Learn Synthesis with Pure Data. Thank you for joining me, and I'll see you next time. Sorry about that. I do have to get the closing in. Oh, I'm hitting the wrong keystroke. Hey man, if you want little outtakes like this, I include them in the videos.